Hello and welcome to this Retrieval Market Demo Day. Today's date is Wednesday, the 17th of August, 2022, and we've got a couple of very exciting talks today. Firstly, we're going to hear from CryptoNetLab about the retrievability Oracle work, and then we're going to hear from Ken Labs about their latest work on Pando and potentially a few other things. If anyone has any questions, please just put them in the chat and we can speak about them afterwards. If you want any clarifications after either the presentations, we can speak about those on the recording after each of the presentations. And yeah, over to you, Irene.
Thank you, Patrick. So let me share the slide. Let's see if everything works. Can you see it?
Yes.
Perfect. Thank you. So what I'm going to talk to you about is this new protocol that we have from CryptoNet, the retrieval pinning protocol. And this is one of the many services that we think are necessary to have for the user to be able to really use the decentralized storage network in the everyday life as useful tools. And the key question that we look at about the decentralized storage network and application here with this project is how we can guarantee retrieval of data stored on these networks. And the answer, the very short, brief answer that I will explain during all this presentation is we think that the best way, one efficient way is using a reliable system of penalties for providers that are misbehaving, meaning they are not providing retrieval. And what we try to do is to design and implement a protocol that implements this idea that is can scale with the size of data. So any size of data can be handled with this protocol, and also the rate of data that can be uploaded to this protocol and treated with this protocol is unbounded. Okay. So let me start with a high-level recap of about decentralized storage network. Usually, what happens there is that we have one user that stores the data with one or more providers, the nodes of the decentralized storage networks. And there is a proof of storage usually mechanism, meaning that no one can lie about storage. The providers can prove that they are storing only if they are really storing, and clients cannot say we are things about honest providers. If the provider are storing, clients cannot say the contrary. Okay, so we are all happy with this. But about retrieval, there is not really any proof about retrieval if it's happening, not happening. It's usually just said that you know, there are these copies of the data around, and there is at least one honest provider that has the copy of the data and will serve the data when the client requests that. That's what we want to solve. We want to go from just assuming there is one honest guy to have more, you know, strong argument supporting that retrieval is really provider. And the first question that comes to mind when you think how you can do this is, can we have a proof of delivery when the file is requested? Because if we have that, then you can think you have the equivalent of proof of storage for retrieval, and we are kind of done, almost. But the problem is that, no, we can't have a proof delivery. There are like impossibility to result in cryptography. There are papers that showing that you can't solve the problem in this easy way, unfortunately. Of course, we can go around this impossibility result, as always, adding some extra assumptions. And in particular, the assumption that we are going to add here is that we have another party, not just the network, the providers, the network, and the client, but we have another party that helps us. For example, one example of this is we can assume that there is the blockchain, that is another party helping us, and the data are all on chain. In this case, the problem can be solved, but this is not a good solution, we think, because data on chain are just like, you can't have the throughput and large data, putting them on chain is expensive, it's not feasible, it's not practical, at least not for any kind of data, it's not web scale. You can partially improve this and solve some of this problem using cryptographic primitives that is called proof of retrievability. But again, so that allow you basically, you don't put everything on the chain. You just put some, let's say, small digest of pieces of the data. But it's very slow. Using this will mean that the retrieval is super slow, especially for large data. So again, not an efficient solution. So what we need in general to be efficient is a third party that we call in general the oracle, the retrieval oracle, I should say. That is a guy that can check the exchange between the provider and the client. And if the provider is really doing his job about storage and retrieval, everything goes well, and and basically the oracle allow for the payment to be sent in the end of the provider. If he sees there is a problem between the client and the provider, and there is a dispute going on because one of the two says no, the file is not, the retrieval is not going as promised, then he can come in and slash one of the two, can discover who is lying and slash in the sense of make some action that is a punishment for the lying, the dishonest part. We implemented this third solution in an efficient way. This is what is the retrieval pinning protocol. If you want to know more about the design, we have a light paper. You can access it by the QR code. Here I will give you just the high-level intuition, how we do this. And the key ingredient is that we have a fixed referee vector of referees. Referees are special nodes that are online, watching basically, not really, just listening if there is a dispute. If there is a dispute, they are calling and we'll have to solve the dispute. Right now we have 5, and we need only to trust 3 of them. They all together, they are our oracle, right? And 5 is just the number that we are using now. It's a good compromise between efficiency and security. You can think about any other number there. And once that you have that, the protocol is simple. So client and provider, they just basically agree on a retrievability deal. So they agree on which files have to be stored and retrieved, for how long, the duration, how much the provider is going to pay, and how much the provider is going to be slashed, taken away if it doesn't provide the retrieval. So this is, they both sign, provider and client, they both sign this deal that is public on chain. Later on, they go and do their own stuff, in the sense that each time that the client wants to access the file, task to the provider gives back the file. If everything is good, we don't see anything else in our protocol. But if at some point there is a problem, the client can appeal. So the client can say to the referees, and can say to the referees, hey, help me, because this provider is not giving back me the data he promised to retrieve. And of course, this client can lie. This could be just a malicious client trying to get an honest provider slash for any reasons, right? Maybe competition, you don't know. So the referees can't trust the client. What they do, they go to the provider and test if this provider is really providing the service of retrieval or not, just asking again the file. And we have I don't want to go to the details here, but we have all a mechanism to do this in a reliable way, both for the client and the providers. If you want to know more, go to the paper. I don't want to give details now, too boring maybe. It's not interesting, I think, to see the app. So you can play with this. This protocol is implemented, and I ask you and suggest you to play and give us feedback as much as you can. And what I'm going to show you now is the video of what happens on the client side. So the client interacts with our protocol through an app, and let's see what happens. So first things, you have to connect with your wallet, and once that you get inside the app, you see all the deals that you have done already, if it's not the first time, of course, that you're using this. For each deal, you can click and you have information about the deal. So the things that we have seen, this is a preview of the file, and you also see all the information about price, this is the file CID, the ipfs CID, or which providers the deal with, blah, 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 the duration, and so on. Note that there is also an NFT logo here, because deals, they are visualized as NFTs. We think this is very useful for using this, for bootstrap the use of this application. You have the information about this protocol, the referees, how many nodes, how many are the referees, how many appeal you can do, because of course we have all these parameters that I didn't say you too much, but yes, the deal, seeing in the chat question, yes, the deal is an NFT. It's visualized that NFT the deal is public information on chain, and we also create an NFT that visualizes that. And I was saying, you have all the information here about the protocol parameters, how many appeals you can do. We have a maximum, of course, to avoid, classic attacks, and how many rounds, so how many times the providers try with the client, the referees, try to recover the file for you, blah, blah, blah. These are protocol parameters that can be changed, but are public here. What else we have? Of course, you can create new deal, the most important part, right? Creating a new deal is quite simple. You just upload the file. This create the ipfs ID, the CID. You select the provider, select deal duration, payment, and collateral. And in this base mode, all these values are basically suggested by the app itself. So the client just choose if you want a free deal, a high deal, you want to pay more to have more guarantees. It's very simple, very intuitive. And then transaction is made on chain and the deal is on. What you also can do as a client, you can choose the expert mode here. When you choose as expert mode, you can play a bit more with our app, meaning that all the parameters that are needed for the deal now are free to choose by the client. So the app doesn't suggest any default value, but you are free to play the market as much as you want. Of course, there are more risks in this case. And as you see, all the risks are showing this in the warning, the box warning, but you can do this. We think the client's completely free to propose any payment or anything else as collateral to the client. And every time, of course, the deal proposed has to be signed as a transaction from the client side. I think we have just seen also, as you see, you can, okay, here is happening that once the deal is active, that is the provider on the other side is also signed. What happens is that you can ask for an appeal. So the client can go back here at any point if something is happening, something is not working with the retrieval, and create the appeal. This is just the button here. This send, and again, a transaction on chain. Referees will start to work, and you see the work that they're doing in if you click on the deal, you see how much you see the process of the appeal from the referee network, and then you will get the file back, or if you don't get the file back, the provider is going to lose the entire collateral that he put on stake at the beginning of when he signed the deal, basically. So this is the side of the client. I want to show you also the provider. For the provider, we designed a command line interface, and the code is public on GitHub. Here, the QR code that brings you directly to the repo where you can download it and just play as a provider with this app. And I want to show you a couple of videos. Tell me, Patrick, if I'm over time or if...
No, it's all good. Keep going.
Thank you, Patrick. I'll also will show you a couple of videos about how the provider command line looks like now. And the first step that the provider has to do if he wants to play with this protocol, he has to sign up, of course. Sign up mainly meaning he has to send an address where we can connect with him, referees and all the other party can connect with him to exchange the files and all other messages. This is not, oh, sorry, I went one slide. This is the sign up, sorry. Yes. And you see, this is basically sending the public address and endpoint saved correctly to the disk and provided added correctly. This means that this provider now is in the list of providers with this address. And you know, in the app, we will show up with this name if you choose one or just with the address. And next step for the provider after the successful sign up is decide the policy. So what is a policy? The provider has to decide the minimum price, the max duration, max size. So you will see all these parameters show up now in the video. I hope you can read it. And why has to do this? Because of course, in this way, then we can automatically accept on the provider side any deal that satisfies this minimum. And this is, you know, for the safety of the provider, because maybe the provider doesn't want to deal with the files that are larger than this many bytes, or doesn't want to deal with the deals that are more than 6 months because it can't, because of the hardware, because of its setup. So these are all the parameters that the provider can choose and set up. Of course, the smart contract has some default value. We suggest default value. So if the provider does do nothing, there are default value to that for security, we say here, but we suggest any provider to set up their own values. And here you see the recap of basic of the policy. So the minimum price is how many tokens per byte per second. It's the minimum for providing the retrieval steps that I want me to paid as a provider. This is the minimum, the max size. Sorry, so I don't accept for a deal a size that is larger than this. I don't accept deals that are longer than 1 year. And this is the collateral multiplier. So I don't accept deals that ask me to put as collateral then 1,000 times more than how much I get paid. This is the policy. And now that we have basically the setup of the provider is ready to work, we will see now what happens on this command line when we ask to do accept a deal. And this is a video of the stress test that we did and we are doing. And on the left, sorry, on the right, you see basically the code for the stress test that is going to create deals for this provider. On the left hand side, you will see this is basically the terminal of the provider. Right now the cache is empty, meaning there is no proposal for this provider. And you will see now that once that this goes on chain, that the transaction for these deals is accepted, the provider will, the command line of provider will start to process the request of doing of accepting this. That's exactly what you see now. Deal expires, so there are some the new deal proposal creator processing. There are some recap for the providers, file statistics about size, blocks, hash, etc., and deposit needed recap and can accept, meaning that everything is in the policy, the provider policy. And of course, for accepting, as you see, the provider has to sign that is accepting sending a transaction online. We see the rest of what's happening here. And sending everyone to the network that is accepted the deal. And this is the one in charge of storage and retrieval of this file, where you can find the hash in this message. And this goes on one deal at a time, is processed. So we have this queue going on. With the, okay, I think we are ready for this. Want to conclude talking about a bit next steps. First of all, I really would like to see more people playing and testing our protocol. So please go to the DApp or to our Git repo, and if you're interested, test it and let us know if you have any feedback, even just on this presentation, if you're not testing the protocol. And one useful way to do it, one easy way to do it is just join our Slack. We have a channel on the Filecoin Slack, and if you write there, we will answer for sure. So what we have done in these past months is basically trying to add all the features to make this idea that this is 1 year ago was just an idea to go from just a prototype to a real product that can be tested by users and hopefully can launch later on this year. What we are discussing now, and really if you have feedback, please tell us, is we think that for a product, it will be nice to have more than just only one referee network. So we would like to have a different referees network with maybe different parameters and let's say service agreement parameters. Of course, we want to contact storage provider. There was a question before, I think. Yeah, so this is a good point to ask Peter question. It doesn't interface on Filecoin. I mean, the interface of Filecoin will be go to Filecoin storage provider and ask them to sign up, the simple way I showed you before, and start to test this. We haven't done that yet because it was too early. It wasn't, all the code wasn't ready. We are planning to do that next month, starting from next month. Minimum, and we can set up parameters to help the providers to use this in the best way. And also we have to find the referees. The 5 referees nodes right now are just all controlled by us, but that's not the way you want to do this, right? You want to have a decentralized, as much as you can, decentralized solutions. So we really would like other institutions, teams, projects to run one of the nodes that implement a referee. So we are thinking about making a referring program to onboard people that can maybe interested to run this. Again, contact us if you have interest here. Then, of course, this is, as Patrick saying, is in the chat. This is for now is written for working on Ethereum, and it's live on a Rinkabyte, one of the Ethereum testnets. But we want to think about how we can bring this to work with the Filecoin virtual machine now that we have one, and this requires some some thinking and of course design work. And last but not least is, and this is a bit like, this is all for very focused, the first 3 points very focused on this project. The last one is more general, because we think this is just one of the many services that are needed to bootstrap the use of decentralized storage network like Filecoin and others. So we would like to generalize the interface that you have seen for having the retrieval, pinning, but also other services. Other services, for example, could be automatic renewal, what we call the perpetual storage contract, meaning that I do a storage contract for 6 months, but I want to have a method that automatically renew the storage deal as long as there are some tokens found in a wallet, in a contract. We are working on the high-level design for now this, and hopefully we will have this implemented and we can pack all this together in a larger project that offers services for online on-chain storage. And that's all. I don't know if there are more questions.
Awesome, thank you. Yeah, any particular questions on what we've just seen?
Yeah, I had a question. Hi, I'm George, by the way. I work with the Magway team and we're looking at payments in the retrieval market via state channels, payment channels. And if I understood your presentation, which is very nice, by the way, correctly, you're adding like an additional economic incentive for providers to like actually provide, so they can get slashed, punished if they don't provide the file. How do you see that incentive mechanism working alongside the existing thing where if you don't provide the file, you don't get paid by the client? Like, is it going to be like a much heavier penalty than not being paid for like very key files or something like that? Or like, how do you see those two things living alongside each other?
Yeah, as you said, is we think that missing the reward, the payment, the normal payment, it's not enough as punishment. Often because maybe the payment for retrieval is not clear how much retrieval is going to be paid. If you think about, always do I think it's useful to understand this, always doing a comparison with the storage and, for example, Filecoin, right? So in Filecoin, storage is not really paid by the client. There is the block reward that subsidize the storage, right? And if you fail to provide storage, like specifically in Filecoin, you fail the daily check that is called window post. Of course, you will miss for 24 hours some block reward, but we also need to penalize because that is not enough. You are actually breaking the slab with the provider, and that's not enough because sorry, with the slab with the client, and that's not enough in the crypto economic mechanism. So there are some penalizations that is going on, and we think we need the same for retrieval to really incentivize the provider to care about retrieval as much as they care today about storage. Does it make sense?
Yeah, I think that makes sense. Just one like quick follow-up. Like, do you think it might put some providers off a little bit? Like maybe they only have 99% uptime or something, and that they could be a bit frightened of being slashed for a small drop in service?
Definitely. That's why they should not be slashed if there is like a small drop in service, and that's why this referee network has to ask to we design the appeal process of the referee in a way that we give more than one attempt to the provider to prove that he's honest. Of course, if you have to, that's why it's difficult. You can't just slash every time. It can trust the client. Yes, definitely. Yes.
Okay, thanks a lot. I'll dig into the paper and stuff some more. Thank you.
Thank you.
Great. Yeah. Any other questions? I've got a quick one, if that's okay. Firstly, it's really cool to see that we're exploring some of these crypto economic mechanisms around retrieval. I was just wondering, we've got a smart contract which is governing the deals that are being made between retrieval providers and clients to ensure that they are going to make them available for retrieval. If I then appeal so that a referee is going to check whether it's retrievable, is there any part of the smart contract which then checks that the referee has done its job properly, or are we just kind of trusting them to do that work?
So we trust in a way, we trust the referee to check each other, kind of. So if enough of them are honest, and usually it's half of them, but this is a parameter that we can play with. If a good fraction of them are honest, then we are fine. One like a small fraction of dishonest referee can't make anyone lose collateral or money.
Okay, great. Thank you. That's really interesting. I'll look forward to looking at the docs. Next up, we have Ken Labs.
Hello, everyone. I'm Ben from Ken Labs. I'm going to show you the Pando ID of DID and VC in Pando. The agenda of this demo, I will introduce the DID peer method. I'm going to show you the Pando ID, which uses the DID peer approach to give customers ownership of their own data. Finally, I will introduce the next development plan of Pando ID. So, What is DID peer method? Most documentation about decentralized identifiers describes them as identifiers that are rooted in a public source of truth, like a blockchain, a database, a distributed file system, or similar. This publicness lets arbitrary parties resolve the DIDs to an endpoint and keys. It is an important feature for many use cases. However, the vast majority of relationships between people, organizations, and things have simpler requirements. When Alice and Bob want to interact, there are exactly and only two parties in the world who should care, Alice and Bob. Instead of arbitrary parties needing to resolve their DIDs, only Alice and Bob do. Peer DIDs are perfect in these cases. In many ways, peer DIDs are to public, blockchain-based DIDs what Ethereum Plasma or state channels are to on-chain smart contracts, or what Bitcoin's Lightning Network is to on-chain crypto payments. They move the bulk of interactions off-chain, but offer options to connect back to a chain-based ecosystem as needed. Peer DIDs create the conditions for people, organizations, and things to have full control of their end of the digital relationships they sustain. In this use case, any unknown party can request a DID document resolved to a public service, for example, blockchain service. Pando is not that public. So in this case, Pando and the peers that persist their data into Pando or consume from Pando should interact with a known party only, and DID peer exactly meet the requirement. This is the anatomy of the peer method DID. There are two methods for generating num-aggro. If num-aggro equals to 0, a single key pair is chosen, having all possible privileges with respect to the DID. And it just so happens that peer ID can match the situation of num-aggro equals to 0. So we adopt this for now. This is a good choice. Different software may need to support peer DIDs to different degrees. DID peer is designed to a layer model. Layer 1 must understand at a service level what a peer DID is and how it works. It must be able to tell whether a string is a valid peer DID or not. It must correctly compare two peer DIDs when sorting or testing for equality, taking into account the case sensitivity rules associated with how the numeric basis is encoded. If relevant, the implementation should display a hyphenate and abbreviate peer DIDs correctly. Pando ID is an implementation for Layer 1. We will support Layer 2 in the future. The current implementation of Pando ID is shown in this figure. Provider first creates the ID and peer ID locally, and then registers them with Pando. Pando provides an interface to register a specific DID with the whitelist, which allows the consumer in the whitelist to consume data. Currently, Pando ID is authorized in this way. I'm gonna show you a simple use case of Pando ID. Let's start the Pando daemon first. Okay, the Pando daemon has started. So now let's transform some data into Pando. Okay, you can see at here we have put 2 nodes into Pando. Let's try to consume it. Oops, there's an error occurred. You may not have permission to access the resource. That's because the DID currently used by consumer is not authorized. So let's change a DID that have authorized. And consume the latest sync, the latest data that provider synced to Pando again. Sync succeed. Step in Pando's plan is that we will implement DID peers layer 2. Pando will store DID docs on a doc chain. Provider and consumer use the secret key generated by the ECDH exchange to encrypt the data during data synchronization. We'll develop a KMS as a part of Pando for key management. And we need to discuss more details about the implementation. Finally, thank you to the CryptoNetLab team and thank you for listening.